Hello guys. So first of all, my patrons and those who follow me on community threads were expecting to get a new weather system, but recently I've been working with Prismatic ADF and my brain is kinda washed. So to fill up the gap, I decided to make or remake procedural stylized grass. Like my previous tutorial was about stylized water, and weather system, I guess, will be in the backlog for another week. So the first thing is to make the model. Yep, the mask for our grass will be generated in the shader, but the shader should be applied over some model. And for the model here, I'm going to use the simple representation of a plane. Right now you can see how the texture is applied, so we can get the idea of the UV setup. So basically it's the default one from top left to bottom right, like 0, 0 to 1, 1. And all I have is subdivision by 4. So once I'm gonna use the world position offset to add some wind, this subdivision will make my grass bend better. Next thing is to make some changes inside the project settings. I used third-person character templates, and some of those features are checked already, but if you have the blank project or it's your custom setup, please follow this one. So all we need is located inside the rendering tab. So here we need to get next. To have the better look and better performance also, I actually recommend to switch off the lumen and virtual shadow maps. So basically it's the setup from the Unreal Engine 4. So let's go up here and disable dynamic global illuminance method. Shadow map method back to shadow maps, because if we're gonna use the virtual shadow maps, we can't get control over the shadow amount or the shadow intensity, and to make everything look better we need to have this ability. Also, we need to have generate mesh distance field checked and few more options. Early Z pass, opaque and masked mesh, and mask material only in Z pass checked. Without this one, the foliage, once you have a lot of geometry on your level, will cause the performance hitches. This one changes the pipeline of the render, but in terms of how masked materials are calculated. So this one will help us to keep our performance. And one more thing, it's not necessary, but in case to get all those fancy stuff, we need to check enable virtual texture support. The reason why we get the mesh distance field activated is to mask out the grass under the buildings, under the dynamic obstacles, and our character and AI, and so we can get the render target to have everything work, but I tried to keep this one like advanced and easier simultaneously. So I also a fan of the Zelda, and as I said, I recreated my previous tutorial, my previous design, and that's why all the masking, all the interactions with the grass and so comes from the mesh distance field. To make this work with dynamic obstacles like our character, we need to add the cylinder. I have this one up here, and change its scale. Also, make sure to disable collision preset, so it should be no collision. And one more thing is to check on and OC. So if you have this one selected, this mesh won't be rendering, but the geometry will be calculated with our shader to have all the interactions, all the masking work. Next is the landscape material. The changes that we need to add to existing one or to create the new one. As you remember from the beginning, we checked the runtime virtual texture. The reason is kind of obvious, because with that we can sample the texture that we're gonna use for our landscape, and from this sample we can get the color and use this color to make transitions between the landscape and grass invisible. Also, if you have like the noise or different type of landscape masks or layers, the color there will define the bottom color of your grass in my approach. So let me demonstrate this one. We have our landscape. We have this color of our ground. We're gonna select the landscape material instance and change its color to something different. So now you can see the grass, its bottom up to the top, and the transition is also calculated in the shader of the grass. Leads to the following result, that we have the new grass, the new landscape, and we don't see the transition edge between those two entities. Like this. To make this work, we need to make few changes. So let's gonna talk about them. Those who have never worked with the runtime virtual texture, here's the quick setup. First of all, we need to add the runtime virtual texture asset. For this, right mouse click and inside the textures select runtime virtual texture, obviously. Once this one done, we need to define the content that we can store to use as a sample inside our shaders. So for this tutorial, I'm going to use on the base color, because that's the only information that I want to retrieve from the landscape to use with my grass. And I need to select enable continuous page update to fix some artifacts that make your runtime once I work a lot with the landscape and runtime virtual textures. Next thing is to add the runtime virtual texture volume to your scene, and to make sure it covers both negative and positive bounds of your landscape. So mine looks like this. That's the reason, because I want to get the color information from the craters, holes, and from the mountains and so. So if the size, the scale on the B-axis won't cover tops or like bottoms, your grass won't be rendering properly. So once you add your volume, you need to select your landscape, select snap to landscape, and set bounds. Then adjust the position of it and provide your texture here, so this volume may know where it should store the old data. Next thing, select your landscape, and here we need to look for runtime or draw in virtual textures. Here we add our runtime virtual texture, so this landscape will be drawn inside this asset. One more tip before we start making our grass. We need to select the landscape inside our outliner, and here we need to look for effect distance field lighting, because if you want this one to generate the mesh distance fields, this will lead to the following artifact. You may see that now our landscape tries to generate this mesh distance field data, and it has intersection with our grass and other elements, so you may see how inappropriate and incorrect this one works. So for all elements that should not be used for interaction, we need to deselect or uncheck this checkbox right here. So in case we select this one, this ramp, you may see once I start dragging it, the grass disappears and we have this nice effect. But once I deselect effect distance field lighting, you may see the grass goes through our mesh. So all the objects that interact with the grass should have this one selected, but landscape should not. So guys, finally we are in shader, and this one is the placeholder for the landscape, and here comes the magic for the RVT. We can get RVT output and provide the color which we use for our landscape to the base color. You may see that this attribute is the same as here, and that means that once we sample, like we have here in our grass, from our landscape texture base color, this is going to be used to colorize the bottom of our grass. So let me show you how it works. So right now I store this to our RVT, but the base color of our landscape now is black. So if I apply and go here, you may see that this one is broken, but the data for the color that we stored inside our landscape actually still provides in the grass. So that means that if I try to sample runtime virtual texture, select the one that I created, make sure that the base color is the only constant here, or if you have not only base color, and so just provide this one to so this one attribute will be similar to the one that you have inside your asset. Now we go like this, provide base color up here, press apply. Now you may see that everything works as it should. Other thing is to use the grass node here, and once we have one applied here, it means that the grass will be enabled or available over the whole landscape material. It's just the preview. Here in the grass node, we need to provide the grass type that we should create. So you may see I have one here. Press right mouse button and select, I guess, foliage and landscape grass type. Once you created this one, you can open up yours And here you can make any changes. Like I have 3 types of the same plane, but with different setup. So I have like medium grass, high grass, and like in between of them. So like short, middle, and high grass. With different grass density, different placement jitter, but they all use the same plane. So the reason why I have few of them here, because grass density for one sample is limited to 1000 units. And for like very waste grass, this one is kind of small. It's not enough. So to make this one work better, we simply need to add few of them here. So we're gonna start with the color, or actually we should start with the setup of our material. So it's our grass, it's masked, two-sided. What else? Tangent space normal deselected, and we have the custom UV set to 3. I guess that's all fancy here. Yep. And I'm going to explain why I do need those and this particular setup just in a few minutes. But let's start with the color. So we sample runtime virtual texture, and the top color it's the vector 4, and for our alpha we use this operation. Texture coordinate mask G simply returns the linear gradient, so it looks like this. And yep, I also do have a lot of vector 4, so instead of using the scalar, this helps me to have my graph cleaner, and it's kinda already have category, so those elements are only available in this particular controller. So how this one works. The offset here defines the offset of the mask. So in case we have like 0.1, we have it's shifted to the top, or if we have minus 0.3, back here to the bottom, minus 0.5, and so. And sharpness here is multiply for the power to make this transition smoother or sharper. Like, let's actually have this one like this, so you may get the idea. And back to normal. Something like this. So make sure that this sample from your RVT has the same asset up here that we use for our landscape, inside the landscape material, inside our scene. Normals. To get this flat, stylized look, lots of people have two choices. Lots of them will tell you get 001 vector provided to the normal, then deselect tangent space normal inside your grass shader, and this one will work. With one flaw. So as you can see, shader made its changes, grass looks good as it should, but this doesn't count the world normal from the slopes. So now you may see on the hills this looks ugly. We can actually have buff visualization from our world normal, and you may see that world normal from our landscape is different from our grass, and we need to handle this one. So here's the trick that I learned a long time ago, I guess maybe 5 or 6 years ago. we get rid of this vector, we search for the customized UV, and we add 3. And UV1 and UV2 will be our buffers. So we can sample texture coordinates nodes, and you can see that we can change the index. 1 and 2 will store this information, so that's why we need sample each of them with the index 1 and 2. Alright, but UV0 set to none, so that means that we can manipulate with this one in our shader without like worrying about something gonna be masked. So we transform the local space of our mesh to the world space, and we mask RG, it's our 0, 0, and store it to the UV1, and the B channel, it's our 1, to the UV2. Next, because texture coordinate stores 2 indexes, from the first one we don't need to do anything, but for the second one we need to mask out the red channel and append together, so the end result will look like this. And once we provide normal map here, you may see that now the direction of the normal map, or just the normal of our grass, is similar to the world. Here I have simple wind controller, linear gradient with the black bottom, so this one prevents the grass from jiggling at the bottom once the wind is added. So simple grass wind with intensity, weight, speed, and so multiply over the vertex normal world space, set to wind. Here add to the world position offset. And yep, I'm gonna stop at the end and show each of the graph independently, so you can press stop button and get everything. Now comes the interaction and masking. So also this one shape control is for this one, so just remember to get this one with styling, height, and wiggle. And those values, like the height, styling, power, are absolute controllers, like the width and the height of my grass calculates from 0 to 1, but the proportion for each straw use random number. So interaction. This one, distance to nearest surface divided by the interaction area, saturate -1, will generate the mask around the mesh or character which has the primitive component that can affect the mesh distance tint lightning. So if I plug this to the color and launch the game, you may see that everything with the black one doesn't do anything, but the white mask around our character or here around the building, it uses the information of this one to manipulate with the grass. So even if I go like this, if you take a look how this one works, let's say we get this one, we pick this up, you may see how the grass is deformed. Once we have white mask affected, we set opacity for our grass to 0, and for those that are on the edges, it distorted to the sides. So back to this one, We also need to have distance field gradient, normalize to get the direction, and multiply by power. This the power, and we use it as the side. So this the distortion from left to right and from back to forward. And we don't need to distort it on the z-axis because we're gonna mask everything to be unrendered. This one is actually the gradient which say how exactly the grass should be distorted, in which way. So we mask G channel, and this one return top. We use 1 minus to get this one at the bottom and multiply it by itself, so the shape looks like the bowl, like this. So it means that like in 45 degrees, yep, our grass will be distorted to the each of direction because we use distance field gradient. So if I take my material instance, go to the interaction controls and place it like this, you need to see how area expands like this and how the sides are affected. Straight to the top, outside of the whole area. Also, I have distance to nearest surface divided by 70, and this one is going to be no grass. I use this one as the multiplier here, once the shape is generated, to say that if the distance to nearest surface is 70 units, everything will be unrendered, and that's all. We need to achieve the following mask. And this mask is generated fully procedural. The idea is kind of simple, that I used in my previous approach. We have the UV space. We need to sample it so each straw will have its own UV space. So it's like, it was like from 0 to 1, but now this one will be like, if it's 0.2, the local one will still be like from 0 to 1. Up here, even if it's 0.4. So you get this one. This one is the global UV space, right? From 0 to 1, but inside each of the straw, how many times we tile it, we need to have its local UV. Then we generate those straws or bands, but they should not be the same height. They should have some randomness. So up here, like this. And we need to, why we need this one to be the UV space? Because if this one returns the UV, if you multiply by the radial gradient, we can actually make the tips or tops to be more triangular form. So it will be actually like the grass plane, something like this. So also we need to control the overall height, width, but proportions of each should be changed with the seed of the random in a proportion of this from 0 to 1 range. We also can have the wiggle to control the distortion, so we won't have this one straight, but wavy one. And this might occur for each straw. So that's how we're gonna get this one. To sample each straw, we need to do the following operations. We need this one. texture coordinate multiplied by number, floor, and divided by the same number, mask R, so it's our vertical. It's our vertical direction, which will return the following bands. But you may see that the gradient is from black to white. Use per instance random, add everything and multiply by the big number. Use frag to generate the actual randomness inside these bands. Something like this. And the intensity of this one, while we subtract everything or add, will define the width, the height, in the proportion of this incoming value. So this one, clamped by this, is actually the width of our grass. To make the UV space for each of the straw, here we need to have the following operation. UV multiplied by the following. Grass tiling that we have here is our red channel. And we use append 1, so this one will always return the same, sorry, not this one, the same number of bands on the same channel as we did here. And 1 is always up here, so we'll only be changing the vertical size of our straw, but not the width of them. So here they will be in the UV space the same. We mask red channel, add minus 0.5 divided by the width here, and add 0.5 again to make the mask at the center of each of UV space. So, I mean, if we start previewing this one, or actually, let me show it up here. If we simply divide it like this and append like this, you may see that we have straw on our left up here and so, but we need to place each of straw inside this one big UV space. So to make this one, we need to subtract 0.5 first up here, and then after dividing, add this one back, like this. So this one is done, and we append the red channel with this shift of the width with our green channel, which always is the 1. And this one return the UV space for each of our straw. Next, we need to add the wiggle. So in terms of the UV space, if we add something, we change the, like we make it a distortion. Хорошо. Over the UV space. And here how I do this one. Texture UV mask GN -1 is to make the wiggle of our grass only on the top. So if I preview this one, I'm gonna change the wiggle power. It's where it is, it's up here. You may see that the bottom stays the same, but the top comes more wavy. Like this. And to make this one work as it works, I have texture coordinate, mask RNG, add everything, multiply by power, and use sign up here. You can actually change and add time and make this one not to be the static attribute, but to be animated. Instead of multiplying, I should add time to everything. And here you may see that we have this wiggling effect of our grass. So if you don't want to use the world position offset for the wind, you may also have the per instance data added up here, and each grass up here will have its own kind of wind intensity. So we append 0 to the wiggle, because we don't need to have distortion of our green channel, but only for the red channel. And this one goes to the UV, grass UV. And this grass UV goes to the radial gradient exponent. Now we need to calculate the center position, so we can have those tops of our grass to be triangular form. So if I unplug top center position, you may see my pattern. To make those triangle tops, you go up here. So after we calculated the straw intensity, we multiply everything by the big number and frag to get the randomness inside the height of each straw. So if I gonna make this one like this, you may see how the pattern changes. Yep. Next, we need to multiply 0.5 and add 1. This one will be the green channel for our position of the top radial gradient. Because if we don't do this one, simply go up here, you may see that we have the upside down and so on, but grass should start only from the bottom and it should not be inverted. 0.5 here represents the center of the top that we're gonna apply over our mask. So if we go with, let's say, 2, you may see that we have this kind of artifact. So it should always be in its UV space, 0.5. So one more time, take a look at how this one is made. Make sure to, if you don't get this one as the attributes from the vector 4, I have the names for each named reroute node, so you can get the idea of which controller I use here and why. So once this one is done, the last part is to provide grass height to the radius, top center position to the center position of our radial gradient exponential node, and grass UV to the UV. Everything up here multiplied by no grass mask, this one, and everything goes to the shape. So guys, one more time, I'm gonna show each of my subsystem, so you can stop and copy paste this one. Let's start with the color. Normals, wind, shape controls, go for the shape, interaction, masking under the mesh, shape, wiggle, random controls, finalize, mask. So guys, that's it. I hope you like my tutorial. So as always, thank you my patrons, my subscribers, those who support me. Leave your comments, press like button, subscribe to my channel. As I said, I have Patreon and project files for this tutorial and other. You may get there via the subscription. Link is under this video. And see you soon, guys.